Greetings everyone. Here, Zufar from Sepuluh Nopember Institute of Technology Indonesia will present my project that is design of HDL-Compatible CC-OFDM-MIMO radar signal processing system. As we know, radar has a wide range of applications in both civilian and military fields. As radar technology develops further, the problems regarding to it arise as well, as shown in the slide. However, in this project, I will highlight the problem number 3, which can be solved by using FPGA. To design the DSP system of the radar, I use Simulink because it's powerful for dynamic system simulation so that we can see the signal flow over the time that represents the actual work of the system. Simulink also has HDL coder add-ons that support HDL code for FPGA implementation. So, the goal of this project is to design and simulate the radar DSP system using MATLAB and Simulink and generate HDL code of the system using HDL coder to be implemented in FPGA board. And here is the methodology I use. The first is designing the system in Simulink. Second is simulating the design system. And the third is generating the HDL code of the system using HDL coder. Here is the overall radar specification, which will be the reference for designing the system. And here is the HDL-compatible Simulink model of the system with the input of sample signal and the output of range and velocity of the target and beam information indicated by index number. This model consists of 3 main subsystems. Those are buffer system, range processor, and velocity processor. The buffer system is used to collect all the signal samples into vector form for further processing. The range processor is used to obtain range and beam information. It uses cross-correlation technique in the correlator block that results the lack of received and reference signal for range calculation, and the correlation value used to be compared with the other correlation value from other correlator for beam estimation. It also collects the slow time sample, which will be used for velocity processing. The velocity processor is used to obtain velocity information. It collects the slow time sample from each observation into parallel form used as the input of 60 points FFT block for Doppler frequency shift estimation needed to calculate the velocity of the target. After the design is complete, I add the radar echo signal block and displays for each output of RSP blocks to simulate the system. The radar echo signal block contains samples of radar echo signal which have certain target information. In the first simulation, the echo signal contains target information as shown. We can see that the results have small error due to the limited resolution bit and limited points of FFT. In the second simulation, we can see that there are also small errors in the results. In the third simulation, we can see that the system can determine the beam correctly and the small errors are still the same. In the code generation part, before we generate the code, we need to check if all the blocks are HDL compatible by clicking the Run Compatibility checker. If all is good, then we can generate the HDL code of the systems. After the code generation is complete, we can see the generated HDL code in the right side of the window or in the folder we specified before. So, the conclusion of this project are that Simulink can be used to design and simulate the radar DSP system for hardware implementation. An HDL coder can be used to generate HDL code of the system to be implemented in FPGA. To create better system, there are some suggestions and works to be done, such as developing more efficient algorithm, doing system simplification, and using some options in HDL coder. I think that's all from me. Thank you for watching and see you.